My name's Emil Cabot. I'm an MVP in Cloud and Data Center Management. I just lost my power. Principal Consultant at Tricon Elite Consulting and Cloud Architect at Answer Solutions. What I'm going to show you today is storage spaces direct in about as bare as we can possibly get it. Before we get into this too much, I'm just going to start off with my demo because I'm going to be building the entire thing from scratch. So what I've got today are a couple of fanless servers. We'll get into that a little bit later. Right now they're domain joined and patched, and that's just about it. So what we're going to do is we're going to use PowerShell, and we're going to go through the entire process to take these brand new machines with no roles installed and put them into a storage spaces direct cluster. So what we have for the environment is pretty much as vanilla as we get, right? I've got two servers, I've got a switch, I've got a domain controller here on my surface that we're going to use. Okay, so first and foremost, if we go in here to servers and I go to add roles and features, pick a machine, there's nothing, right? It's empty. Okay, so in PowerShell, the first thing that we need to do is install our roles, right? So what we need to get storage spaces direct working, we've got to have our file server. We're going to use failover clustering because we need to have this in a cluster. And of course, we're going to use Hyper-V. So first I'm going to do this on the second host. And then I'm going to do it on the first one. So that's going to go through, and once they're installed, it's just going to reboot. Okay, so Project Data Raft. Project Data Raft was an MVP-driven solution. Prior to the release of Server 2016, in order for an organization to make the jump into hyper-converged infrastructure, you had to go out and buy a full solution, right? Regardless of the hardware that you had to go out to a Nutanix or an HPE or something like that and buy a hyper-converged solution. For you guys that don't know what hyper-converged is, so our traditional our data center environment is what we'll call a converged network. So basically, you'll have your storage on the back end in a SAN, right? And then you've got your compute hosts, and then you've got your network. Hyper-converged does exactly what you think it does. It takes all three and puts it into the one. Right, so these units that I've got here are from an organization in Israel called CompuLab, and they have designed a completely fanless server. So I'll get into that a little bit more in a minute, but they are completely solid state, no moving parts in here at all. Storage Spaces Direct is optimized for SSD and NVMe technology, or non-volatile memory. Also supports spinning Rust if you want to get capacity. But at the very bare minimum, you need to have 4 physical disks for your capacity. And if you're using caching, you need to have at least 2 of those. What I'm going to show you today is about as bare as we can get. I'm actually only using 2 disks in each of these. Not because they can't hold it, they can, but I'm cheap. So I didn't want to go out and buy 8 enterprise-grade solid-state drives just for today. So what I did was I used some 850 EVOs. They're 1 terabyte, they work great for what I'm doing. Don't do this in production, do not do this in production. Solid storage, storage spaces direct, you need to use non-volatile write cache. They need to have power loss protection because this is all flash storage, right? If I pull the power on this, I have a pretty good chance that I'm going to corrupt some data. How much data I'm going to corrupt, that all depends on what's happening at the time. But I can pull the power on this and brick my drive, right? It is possible to do that. So for enterprise grade, you definitely need to have enterprise grade hardware. Also, a quick mention, right now what I'm going to be doing is building a NIC team. So I'm going to be teaming these 4 1 gig adapters on each. For Storage Spaces Direct, we recommend 10 gig infrastructure. Absolutely, we need to make it fast. Because we have shared nothing here, there's disks in this host, there's disks in this host. We're going to be pooling, we're going to be creating a pool across the disks on both, right? And this is for redundancy purposes. If I lose a host, everything still works. If I lose a disk, everything still works, right? But because the data is across both hosts, there is a lot of traffic that goes in between them, right? And that's where RDMA comes in, RDMA over Converged Internet, or ROCI, right? That is the new way of doing this. Mellanox is the organization right now that we're using for their cards because they work, and they work easy.
Can you just briefly clarify, what is RDMA actually do?
That's Dave's session. So he's going to go into all of the performance about Storage Spaces Direct. It's probably over now, yeah. So my configuration, we have 2 airtop fanless servers. These things are great. The only fans on these are here on the top, and they're just here to show that heat does come out of these, right? So they're pretty cool, completely solid state. So I'll pop this, and there we go, right? They've taken the power supplies out, and they run kind of like a laptop, right? The power supply is out here. So now what happens, I can actually put a GPU here, right? So I could put a GeForce 980 right here. And there's plates in here that will dissipate the heat out through the casing. And then if you'll notice on the casing, there's a bunch of little tubes here, right? Air convects up as the heat comes out, right? So here we go. That's a Xeon processor underneath that plate. MSRP on this is 800 and change, bare bones. Bare bones means they come with board, case, and RAM. Or no, board and case. Board and case, right? No CPU, no memory, no hard drives. Right? So these devices here as configured are about $3,000 each. Yeah, the way that I have them. I have them with 32 gigs of RAM, and I have them with no extra video card, and I have them with 2 solid state drives. I have thrown I've thrown 4 2 terabyte spinning Rust drives in here, and then 2 MSATAs for cache, which is a supported solution by Microsoft. Anyway, so those are the machines. For performance, again, this is not a high performance solution. This is a stable solution for small business, right? I've got 2 hosts. I don't need a data center. I don't need air conditioning. I don't need cooling. If this is in a construction place or a welding shop, I don't care. It'll work, right? That's why I selected these, because they're going to work in pretty much any environment that I'm going to throw at them. For performance, we want to have at least 3 hosts for Storage Spaces Direct. Microsoft does support a 2-node cluster, so what I'm doing here does work. I'm going to pop back over into my lab here for a second. And make sure that I can get back in. So CompuLab has a technology that they call natural airflow. And here's the series of plates, right? There's our processor. There's that little black plate that I showed you guys a minute ago. Not really. I would kind of think of the case as a heatsink, if anything, in here, right? So what happens, it's heat dissipation. So the heat's going to conduct from here to here, through the plate, and then into these. These aluminum plates here will right? It's kinetic molecular theory is ultimately what it is, right? So the heat's going to go out through here, and then once it gets out to the outside, it
The side gets hot.
goes up, right? Exactly, yeah. At a box, you can run these off 4 displays. You can get gaming machines like these. So they're pretty cool, pretty versatile. I love them. Yeah, you could do lots with them. That's what I did, is I went out and I was looking for the next newest thing in hardware for SMBs. This is what I came up with, and I have nothing but good things to say about them. These 2 units here I've been running in my lab at home for a little over a month. I've been running about 25 VMs on them around the clock. SQL servers, config manager servers, database servers, just sitting there running. And I haven't had a blip. Wonderful, wonderful tool. P at SSW0RD, because that's our favorite password. Checkyourlogs.net is our blog site. Let's run PowerShell. Yeah, of course it didn't, because it rebooted. But now if I do get Windows feature on here, there's a whole bunch more stuff turned on, right? Everything that I put in that is now enabled. So that's all groovy. So now what we're going to do, after we've got our roles turned on and our machines have been rebooted, we're going to build our switch embedded team. And this is a new feature in Server 2016. Think of a NIC team, but at the vSwitch level. Okay? So we're going to create our vSwitch.
So to say that again, you're going to create your vSwitch and then you go to...
My virtual switch.
Yeah.
So now I'm creating my virtual switch. I've got them created on both nodes. So we're about to cluster these 2 machines, right? So now that I've got my switch built, I'm going to create my what's known as my converged network, my converged Ethernet. So I'm going to create. So I've now taken these 4 ports and combined them all into one vSwitch. Now from that one vSwitch, I'm going to create 3 virtual network adapters off them. One is for my SMB traffic. One is for my live migration traffic, which is a part of my cluster. The other one is for my heartbeat traffic, which is another part of my cluster. So those are now created.
By SMB, you mean server messaging block.
Correct. Server messaging block. So now I'm going to configure my IPs. 6 IP addresses. There we go. Now I'm just going to get the status just to make sure that everything is good. And there's our networks on one server. There's our networks on the other server. Okay. So that's all great. I'm all good. Next thing I'm going to do is I'm going to test the cluster process. This is very, 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 very important for clustering. If you do not validate your cluster before you build it, it is not supported. Your cluster has to pass validation. At the minimum, it can have some warnings, but there cannot be any failures inside of your cluster validation. If there's a failure, it's an unsupported cluster.
This is using a core. This is a 2-node cluster, right?
This is a 2-node cluster, shared nothing. Yeah. Okay, so while that's doing that, the validation takes a couple of minutes. I have only got a couple of slides. Oh, yeah, there's my cluster build at home, right? And that's all I had for slides. So now let's go back over. And this will only take another minute. So yeah, so this is about as low as you can get. You can go out there and look. You can build a supported storage spaces direct 2-node cluster for less than $2,000. There is a way to do it. Special hardware, not special hardware, but specific hardware, right? Specific drives, specific NICs, and it'll work and it's supported. So for the SMB market, you know, if you need to get a certain amount of availability in your on-premises environment, it's not too hard to do, right? It's not too complex. You don't need big data centers anymore. What I'm also using here is a very simple D-Link smart switch. I picked it because it was fanless and quiet. And as you can see in the picture, right, this is my home that I run this stuff out of. So quiet is good. And these are all low power. So by moving from my old enterprise grade machines to these, it saved me about $100 a month in power. Yeah, right? So we're still gathering data over here. How are we doing for time? Okay, we'll make it. If not, I got a video. What else can I say here? Because we're using consumer-grade SSDs, which is not a good idea, we don't get the best performance out of this that we should. However, I still do have availability. Even with 2 disks in each, I can get redundancy off of that. So I can fail a drive. I can fail a host. It's still going to work.
The internal storage connectors, are those SATA or SAS?
They are SATA, SATA 3.
SATA.
Or SATA 6, yeah. SATA 3, 6 gig, yeah.
Why would they be SAS?
Why would they be SAS? Right? We're going away from all that. So the next iteration of these is going to have NVMe technology, which runs over PCI Express or direct on motherboard, right? SATA. The problem with both SATA and SAS right now is that's our bottleneck, right? The bus is our bottleneck. So even moving to SAS we would still be bottlenecked.
It's got a bit of 300 megabytes per second.
Yeah.
Still pretty decent, right?
Yeah. Well, I mean, you know, and we build these, right? We build these on SSDs all the time, enterprise-grade SSDs, mind you, but they're still running through SATA connections, and we're transferring 450, 500 megs a second, right? It all works great.
You can plug the SATA drive into a SAS socket, right? So you get most of the benefits of SAS.
Yep. I think the demo gods aren't being very nice to me. And I seem to, actually, because it's just a demo. Okay.
Is there a window behind it?
Backup plan. Okay, so now I build my cluster. Right, it's already validated. Doesn't take very long because I'm not including any storage right now. Right, so it's just going to connect the 2 up, build the roles. I didn't time slice this very much, so this is, with the exception of the reboot, this is about as fast as it gets. On my next step, I configure a cloud witness. For anybody watching online, I have now killed that security key, so it doesn't help anybody. But yeah, so one of the other things with Server 2016 is a cloud witness. So rather than using a file share witness as was very popular previously. What we can do now is use an Azure storage account, right? So that takes all hardware out of the mix. So because I'm only using a 2-node cluster, and I don't have any other hardware.
But then this thing has to be internet connected, right?
Yes, there you go. Cloud Witness, of course, it has to be internet connected. Yeah.
How much bandwidth? What's the minimum?
Oh, yeah, no.
I'm thinking if you set it up in a remote, mining
Yeah.
site or something, where
Yeah.
you might have a satellite.
Yeah, it's fine. Yeah, it's not a whole lot of data at all, right? It's just to make sure.
Or else that link goes down to everyone else's.
So I can fast forward. There you're forming the cluster, and then she all gets created. And then away we go. So then, well, look how fast it happens, right? I live in the sticks, so I don't have a fast connection. 4, 5, 6, 7, 8. Shouldn't even take that long. My time, look how slow it's going. It's like 3 seconds. It doesn't take very long. There you go, Cloud Witness. Okay, so then what I do is I run a get storage subsystem. And what this is going to do is this is going to tell me if my drives are ready, right? I want to see health status is healthy. I want to see operational status is okay, right? So then what I'm going to do is I'm going to get my physical disk. And same thing, I want to make sure that my disks can be pooled. Right, so when I run the get physical disk, again, operational status, I also want to make sure that I can pool them. You'll notice one of my drives here, I can't pool. It's my OS drive. Right, your OS drive has to be separate. Your storage spaces direct drive cannot be on your C drive. They have to be. Right now, these drives were left initialized in Disk Manager, and that was it. There was no partitions on them or anything. So here they are sitting like that, and that's the way they need to be to build our S2D cluster. So once we've made sure that everything is okay, the process to enable storage spaces direct, once we've got our cluster built, is actually just one line. For some reason, my video is very laggy. But yeah, even on the video, right? Demo gods aren't happy this afternoon. But there you go. So then I just enable cluster S2D. I give it a friendly name for the pool, and I don't want a pop-up. And in real life, it doesn't take very long. In my video, it seems to be taking very long. So then, once my cluster has been created, I create a couple of volumes, right? So what I do here is I could specify the level of redundancy that I want on my drives, on my volumes, right? So by selecting physical disk redundancy of 1, I can lose a disk. I can lose a disk here, I can lose a disk here. Once she's done, you go into cluster storage. There's my volume 1, volume 2. And you see in disk management, my disks are gone. Right? They're now maintained into the cluster pool. So if I go into Cluster Manager, here's my 2 nodes. There's my cluster pool. There's the 2 volumes that I just created. Right? And then I can go through, and of course, create a virtual machine. and install server 16. So realistically, if my demo hadn't blown up, I can get this whole build done from cradle to grave in 20 minutes. That's using this hardware, right? So in the enterprise world, 5 minutes, it's done, right? I've walked ourselves through that script. I can just F5 it and away we go, right? Outside of the reboot, when I install my roles, that's really my only thing.
How much RAM can these things take?
These are maxed out at 32 gigs. I'm hoping that their next ones have more, because I would love 64.
Yeah. The number of VMs is limited anyway.
Yeah, but I mean, on 32 gigs of RAM, if you put on, I mean, for a lab, you're going to turn on dynamic memory possibly. I can run 20 VMs. I can run a config manager server with 6 gigs, and I can run 20 VMs off of that 32 gigs of RAM. No, not really, because it's dynamic memory, right? So, I mean, if everything was maxed out, absolutely I'm overcommitted, right? Absolutely. But again, it's my lab. I'd never do that in production, right? There's a whole lot of rules that we break in the small business market and in the labs that we wouldn't necessarily do in production. But look, our cluster got built. And I can't configure my witness. That's the error that I got, was because I don't have a witness. And I can't set it because I'm not online right now. But now I can go through and get my physical disk, get my storage subsystem, make sure my drives are okay, right? CAN pool true, operational status okay. Same thing. So now I enable my cluster.
How orders one machine goes down to bring it back up?
If it dies and I need to rebuild it,
Yeah.
it's just adding, it literally add cluster node, name, enter. And then what it'll do is as soon as you go, because all you're doing now is you're adding a new server, you're adding a new node to your cluster, right? But because your cluster has already been deployed with storage spaces direct, as soon as you add that new cluster node, it's going to go in and it's going to scan those disks and it's going to throw them all into the pool.
So even the OS is kind of heal itself through the RAID or through replication?
How do you mean?
Well, you have OS disks on both, right?
Yeah.
So will the OS disk be replicated through cluster?
No, your OS disk is your OS drive. You can do a RAID 1 for your C drive, right? So you have a disk mirror, but why bother? I can install Server 2016 in about 10 minutes, right? As you can see, I could build a new cluster from scratch in less than 20. So realistically, if my hard drive dies here, I'm going to pop a new drive in. I'm going to install Server 2016 off of whatever, right? F12 it, use my MDT box, use config manager, whatever, right? And I'm going to, let's say this was, Cabot-Airtop 2, right? It gets destroyed. I don't know how, but it gets destroyed. So I put a new drive in. Now I'm going to rebuild this as Cabot-Airtop 3. Right? I'm just going to add it in as a new node. I'm going to evict the old one, right? And then add it in. So you'll notice here it says no disks found to be used for cache. It'll automatically tier your drives. So if you put in 4 spinning Rust drives here and 2 SSDs and then hit that enable S2D, it's going to know that you want to use those 2 solid state drives for caching. And it's going to create your 4 spinning Rust drives as your capacity, right? If you throw in 10 SSDs and 5 NVMe drives, it's going to create your NVMEs as journal, and it's going to create your SSDs as capacity. All I have in here is SSDs. So it ended up creating them all as capacity. right? So now I'll create my CSV. Clustered shared volume. Yep.
That's built on top of the pool.
That's built on top of my storage pool, yes. Yeah. So now if we go in, as soon as this finished creating,
just to be clear, your pool is a mirror, right?
my pool is a pool. So right now what I've done, when I create my volume, I specify the redundancy level that I want when I create it.
What is it right now?
So here I've set my physical disk redundancy as 1. Right? It's a mirror. Right? So I can lose 1 drive. I can either lose a drive here, I can lose a drive here, I can lose a host. I can do physical disk redundancy 2, right? And then I can lose 2 drives and not affect it. I can do 5 and so on and so forth, right? So now that we've got our drive, I can go in here and I can go to C, cluster storage, just like your cluster, and there's my volume 1, right? 200 gigs. Now, case in point, and just to prove to you guys that using consumer grade hardware for all this stuff will give you your resiliency, but it's not going to give you your performance. Right? You guys seen the inside of this. These are solid state drives, right? We all know how fast these things run regardless of whether they're consumer or enterprise, right? I take my ISO of server 2016. Ideally, I'd like to see 400 megs a second here. Not going to happen, right? Because again, I'm running with 1 gig NICs here. There's no RDMA, right? Nothing here is enterprise grade. It's just a home switch. The switch doesn't even have a fan, right? It's an unmanageable switch. But I don't care about performance, right? As an SMB, as a small business, I don't care about performance. I just want the stuff to work, right? I mean, I've got, 6, 8, 10 people in my organization. I just need a file server, right? I need to make sure that it's always there, and I need to make sure that it's backed up, right? I need a little bit of availability because, even at 6, 8, 10 people, I don't want to lose work. But I also don't want to break the bank for something that's not going to make me any money.
Right now, what are you copying a 1 gig file?
I'm copying a 5 gig file.
5 gig file to the cluster?
To the cluster from my C drive. So it's actually going from my MSATA drive to my solid state drive.
SSD drive.
Yeah.
But it's also being written at the same time.
That's right.
Physically to the other one.
Yeah. So now once I get this into my volume, right? So I'm sure the lights here on the front are just going nuts right now, are they? Yeah. Right? Done? Almost. Right, but the point of all this is that Storage Spaces Direct is here. Right, we don't need to go out to these big hyper-converged vendors now and give them $250,000 to get 15 terabytes of flash storage. Right, we can do, we can give you guys 37 terabytes of mixed spinning Rust and NVMe on enterprise-grade hardware for like 25, 30 grand, right? It's super cheap. And that's Project Data Raft, right? Project Data Raft are these scripts that build your S2D cluster, right? So that you don't need to go to these big vendors and have to deal with their markup to give you something that Microsoft provides you for free. So now I copy and paste this. And again, if you guys want to see the performance of Storage Spaces Direct, on enterprise grade hardware. I'm guessing you missed it today, but the sessions are up on channel 9, so channel9.msdn.com. We went through it in Edmonton on Monday, and we will probably be doing them as well on Friday. I don't know whether they will be recorded or not, but Dave and Crystal do a beginner's session on Storage Spaces Direct, and they take you and answer all the questions like, why do we need to do RDMA over converged Ethernet, right? Why RDMA is even used in this when we're looking at 10 gig infrastructure already, right? Clint does a performance session, right? This is how you troubleshoot these things when they're slow. This is how they should operate, right? This is the speeds that we should get. But here you see, right, consumer grade SSDs, we got 1 gig NICs, even though we've got a team of 4. There's a lot of things that I have not done to this S2D build that will typically occur in a enterprise implementation. One of the things that we're going to do is we're going to implement QoS, right? We're going to do net QoS on those NICs so that we ensure that SMB traffic gets that priority, right? We need those disks to be able to share as fast as they can. So we implement a lot of QoS. The production script to implement this versus what I have, it's about triple the size, right? And that's without error checking. So I cut a lot of things out of here that I would not cut out in a production implementation. So we will put the script up for you guys to download. It's a great place to learn, and it's great for your lab. Don't do it in production. Don't do it in production. Don't do it in production. If I didn't say it, don't do it in production. Yeah, this is not supported. However, the reason why Microsoft has a requirement for 4 disks for capacity is for redundancy purposes, because disks do fail.
Is that 4
right?
disks in each one? Or
I don't. I only have 2 in each one. It still works.
4 total?
Yeah, but Microsoft, in order for this to be a supported configuration for Microsoft, it needs to have 4. I just didn't want to spend the extra $2,000 to put the other disks in there. I really didn't. So anyway, where was I? Disks, right. Oh yeah, virtual machines. So what I can do here is, if I didn't want to cluster these, and I didn't want to do the S2D build and all of that, what I can do is I can turn this into a Hyper-V box with 32 gigs of RAM, or 16 gigs of RAM, or 8 even if you have it, and I can create 2 virtual machines. In those virtual machines, I'm going to install Server 2016. Once I install Server 2016, I'm just going to go into Hyper-V Manager, and I'm going to add 2 disks. I'm going to build up another box, another VM, and I'm going to have 2 extra disks in there. Now I've got 2 initialized disks in VM1. I've got 2 initialized disks in VM2. Guess what I'm going to do? I'm going to run my little script, and I'm going to build an S2D cluster. So you can build a Storage Spaces Direct cluster out of virtual hardware. When you build your Storage Spaces Direct cluster out of virtual hardware, your requirement for capacity goes from 4 drives down to 2, right? VHDs don't burn out. Microsoft understands that. That's why the requirement is lower, right? Your VHD is not going to die. You up next? Okay. So there we go. So we copied. So as we've seen, right, we're getting about 50 megs a second-ish on transferring. For a small business, that's fine, right? Again, this might be $6,000, right, here on the table. For an organization, that's not bad. Any size of an organization, that's not bad, right? Considering now what I have is really 4 terabytes of solid state and enough Hyper-V compute and storage to run as many virtual machines as my organization would need. And then, of course, we have Azure. Questions? You can go offline if you Thank you.